So who needs? Who's got a question? Very good.
Can you do number 8 and 9 on like the?
This page right here.
Yeah, I just like don't understand.
All right, so it's kind of like overlapping stuff, so it's kind of good to see. Right, so it says the diameter of F and G are 5 and 6, right? So if I'm looking at this right off the bat, the diameter of F is 5. So if I were you, I would put a 2.5 right here. You agree with that? Now, and then if you want, you can say from here to here is how much? You agree with that? And then that's 3 also. You agree with that? Do you see that or not? Well, because it tells you. Right, it tells you here.
Because 6 and then the radius would be 3 and that's already 2.5.
Yeah. Good. Now, and the other thing is, you know, this right here from A to F is 2.5, right? And we just established that BF is 0.5, right? AB would be 2. That's a good little question.
We got 3 on the word problem.
All right, let's take a look at 3 on the word problem.
Oh yeah.
So it says 3 identical circular coins are lined up in a row as shown. The distance between the centers of the first and third coin is 3.2. Actually, the trick here is determining how many radii that is. Right? So if I'm doing that, I'm not saying you're right or you're wrong. I'm just looking at it. I'm going to draw it from there to there. Right? So that's definitely a radius. That's definitely a radius. That's a radius. That's a radius. So there are 4 radii. Do you agree? That was the easy way to do that.
Wait.
I'm listening.
How is that 4 radii? Like, it's like 3 circles. How is that 4?
Because it's not going from the end of one.
Oh, okay.
Right?
So
again, what I'm showing you is this is what that measure is.
Right. Okay.
All right. So when you draw that, you should be able to look at that and say there are 4 radii. Yes.
What are the 10s in the middle mean? Is that just a
Yeah, I don't know what that is.
It's
a distraction.
Yeah, I thought it was a diameter.
No. Okay. Does everybody agree with that? All right. Again, hopefully you're feeling like that was pretty basic. Yes. All right, let's check out 4 on the word problems. Very good. All right. It says, a rectangular plaza has a surrounding circular fence. The diagonals of the rectangle pass from one point on the fence through the center of the circle to another point on the fence. Based on the information in the figure, what is the diameter of the fence? Well, it says a rectangular plaza. Do you agree with that? Do you hear me? So because it's a rectangular plaza, you know that that's a right triangle, right?
Yeah. What is 245 describing? Is it the radius of the side of the rectangle?
It's supposed to be the side, it's supposed to be A squared plus B squared.
Yes, I'm pretty sure that's what they mean. All right, I'm agreeing with you. If it were me, I'd probably put 245 on the other side.
So because the hypotenuse could be smaller than the side.
Oh, that's a good way of looking at it also. Very smart. All right. Or they could say it's the radius or something. Right. But again, so I understand that. Right. So if I were doing this problem, I would just type it on my calculator, 245 squared plus 377 squared equals, and then take the square root of that. Did it work out evenly?
No, it's a square root of 2,000.
I thought maybe it would work out so you could see it. right? That's fine. I'm totally fine with that. All right. You good now, Joe?
Yeah.
All right. So now let's pull up 10.2. All right. Okay. So now 10.2 again, very straightforward, just formula based. All right. So it should be very, very simple. We're going to talk about angles and arcs. And again, something that's really important for you to have a discussion is you have to know what a central angle is. All right? A central angle is just an angle that's vertex is at the center of the circle. So look up, please. Make sure you're hearing me. This is a central angle because the vertex is at the center of the circle. Pretty obvious. All right? Now, if I tell you this is 40 degrees, then the measure of arc CF is also, guess what? 40 degrees. All right, which makes perfectly good sense, right?
Yeah.
The size of the angle doesn't make a difference, right? The measure of the angle remains the same. In other words, just to make sure you're understanding me, if I draw this angle and tell you it's 20, and if I extend this out more, it's still what?
20.
It's still 20. The size of the angle doesn't make a bit of difference. Does everybody agree?
Yeah.
So now what we're doing is we're just saying if we measure the arc, the measure of that arc is also what? 20 degrees. Makes perfectly good sense, correct? Right? It doesn't matter where you measure along that angle, it's always going to be what? 20 degrees. All right? To me, that was kind of obvious. All right, yes.
So our arcs, they don't act like angles, they just have the same measurement.
Exactly.
Okay.
Now I'm going to say the length of the arc is different, correct? So if I said the length of this and the length of this, they would be totally different. But the measure is the same, all right? And I used to tell kids, think of measure as like you're measuring the angle in degrees. All right, that's how you measure the arc in degrees. The length of the arc, all right, is dimensional. All right, how many inches or feet or yards? All right. Now, there's something called a minor arc. All right. There's something called a major arc. All right, and there's something that's called a semicircle. So your arc that's created is minor if it's less than 180. It's major if it's what? Greater than 180. Now, technically it should be between 180 and 360, right? And minor would be between 0 and 180. And a semicircle would be exactly what? Exactly 180. So again, think about it like that. I don't think that's very difficult.
What would 90 be?
It would be minor.
So not like a quarter.
No. We're defining arcs as either a major arc, minor arc, or you can call it a semicircle. Right? Now, I'm agreeing 90 degrees could be special, but they don't label it as something from 0 to 90 to 90 to 180. It's either less than 180 or greater than 180. It's either major or minor. If it is 180, it's a semicircle. That's all. All right? Now, something that's kind of interesting, not real interesting, but, 360 is nothing scientific. Right? It's just something that a long time ago, the Babylonians decided that because a 360 is divisible by a bunch of different numbers, that we're going to say the degrees are 360. They could have very well chosen 200. All right? There's nothing scientific about 360. Is everybody with me? All right? So it's just a random number that they chose. All right? Now, what do you think the arc addition postulate is? The sum of
The angles for the measurement of the arcs.
right, exactly correct. Or it's just like the segment addition postulate or the angle addition postulate. So the arc addition postulate is the sum of the parts of the arc equals the what? The whole. All right, that's all there is to it. Very basic, very basic. All right, so let's quickly take a look at this and see how we're doing. The degrees in a circle add up to what? So to figure out what x is, we just... Yes, and someone tell me what that is. Somebody said 80. X is 80 degrees. Everybody okay with that? All right, again, please, just go with me on this. I promise you, this chapter is super easy also. All right, and like I said before, part of the problem I feel is like some of you are, when I say it's easy, you kind of start to daydream a little bit and not do the problems, and then it causes a problem. All right, just work the problems with me. All right, so number 2, x would be what? 150 degrees. Any objections? All right. Now here we go. BD and AC are diameters of circle O. Identify each as major, minor, or semi. All right. So BA is what? Minor. BC, minor. Now let me explain to you. It has to be minor. All right. Now look right here up on, because I'm going to show you something I should have said already. But look right here. BC, listen to me, is always the quickest route. If I wanted to talk about this, please watch and you'll see what I mean. If I wanted to talk about that angle, or that arc, sorry, I would say BAC. Bear with me. Or I could say what? BDC. I just can't say BC. Because BC would define the what? Always define the minor. BC always defines the minor. So if there's 2 letters, automatically you know it's what? It's minor. All right? Nope, it's always. All right?
Okay, so I'm like the ones that BADC, that big you said? That one?
So let's just go through it real quick. I promise you I'll get to it. Right? So we already said BA is what? BC is what? Now, CD is what? Minor. Right? There's 2 letters. They're minor. All right, now look. ACB. Now we know it's major. Now, if you go around the circle from A to C to B, you understand what I'm saying. That's definitely major. All right? Now, B to C to D. That's the semicircle. And then AD again is the what? Minor. Anybody have any issues with that? I'm agreeing with you. Very simple. Very simple. Do the problems with me, and I promise you I'm answering your questions. What? Say it again. So did you draw BCD? Tell me how far around the circle you're going. Come on now.
But why is the ACB not a semicircle?
A what?
ACB.
A to C. So here's what you're doing. From A.
Oh, I'm going the wrong way. Okay.
Exactly. All right.
With angles like that, that's obviously a major. You said that the angle measurement correlates to like how big it is if it's 20 to 20. Well, that one's 44. That thing's not 44.
So what they're saying is this measure right here would be 44 degrees. This is 44 degrees. This right here would be 136 degrees. This would be 136 degrees. Because that's 136 degrees.
Okay,
right, exactly. And they're vertical angles and everything else. Again, to me, like I said, guys, I really feel like I don't even need to tell you this. I should just give you the worksheet and say, figure it out. Because to me, it's just complete logic. Everything that you know, if you start to just make observations, that's what I'm trying to show some of you guys. Make your own observation. Right? It's really not a mystery. All right, let's take a look now at something else. All right. Now, arc length instead of the measure arc length. Right? So, If I asked you to go all the way around the circle, that would be called the what?
Circle.
Circumference, right. So your circumference is 2 pi r. Stay with me. Now, let's say I want you to look up. What part of the circumference would that be? Half. Very good. Why is it half? Because it's a semicircle. It's a semicircle. Now, how do I know it's half? Because how many degrees did I travel? Out of how many? Now, the reason why I'm telling you this is because I'm trying to get you to derive the formula for arc length. So, the circumference is what? All the way around the circle. The arc length is a fractional part of the circumference. So your arc length is simply the number of degrees you travel out of what?
360.
Out of 360. So if you want the length of the semicircle, it's just half the circumference. Everybody hear me? Because it's traveling what? 180 out of what? 360. Just like if I said, I want to go this, that's what? 1/4 of the circumference. How did I know it was 1/4? Because 90 out of 360 is what? 1/4. Now I'm saying, let's say X degrees was 74 degrees. 74 over 360 times the circumference. Now look, I want everybody to understand that. All right? All the way around is the circumference. So if you don't make it all the way around, it's a fractional part of the circumference. Is everybody hearing me? It's whatever fraction that you've traveled. If you've traveled in degrees, it's the circumference times n over 360. I just think that's just logic. That's just simple. All right? There's really nothing to think about. All right? So there is your formula for arc length. But we already know that. This is a fractional part of the circumference. All right? So what does that mean down here? Find the length of each arc. Now, do I really want you to round it to the nearest hundredth? No. All right, I'm setting you up for pre-calculus. We don't write in decimals. We write in terms of pi. All right? So in this case, the radius is what? So DE, how many degrees is DE? Which is what?
1/3.
1/3 of the circle. So the circumference is, everybody should be able to just say, obviously that's 4 pi over 3. Obviously, it's 4 pi over 3. What's the circumference of the circle if the radius is 2? 4 pi. I went, what part of the circumference? 1/3. 4 pi over 3. 4 pi times 1/3 is 4 pi over 3. Hear me out now. Make sure you're hearing me. 120 degrees is 1/3 of the circumference. The circumference of the circle is what? 4 pi. 1/3 of 4 pi is 4 pi over 3. That is how I want the answer. I want you to be able to tell me it's 4 pi over 3. And 4 pi over 3 is approximately how many units? Good, 12 meters. How do I know it's 12?
It's almost 3.
Because I tell you pi is what? 3. Does everybody hear me? We don't say pi is 3.14 if we're estimating. If we're estimating, we say what? Yes, that's what I said, 4. 4 meters. Thank you. All right? 4 meters, because 4 times 3 divided by 3 is 4. Is everybody okay with that? All right, the main thing is, look how simple that is. All right? Now, if the diameter is 7, that means the circumference is what? 7 pi. Beautiful. If the diameter is 7, the circumference is 7 pi. If I go all the way around, it's 7 pi. I'm not going all the way around. I'm looking at DEA, which is how much?
712.
210, right? So we could do 210 over what? 360. And obviously that would reduce down to
712.
7/12. 7 pi times 7/12. So we would say the answer works out to be 49 pi over 12. Trust me, that's how I want the answer. 49 pi over 12. I don't want a decimal. Any issues or concerns with that? All right, BC. I'm trying to find the measure of arc BC. BE is what? So the circumference would be what?
24 pi.
24 pi. And BC is what? 45 degrees. Now you should know that 45 degrees is 1/8. Hear me out. There you go. That's exactly right. That's how you should be thinking of it. 90 degrees is what? 40 into 4s. So if you cut 90 in half, you're cutting it into 8s. Think about that now. I'm helping you with what's called the unit circle. Eventually you'll be getting into that. You need to know how the circle is divided up. If I say 45 degrees, I automatically want you to think of it's divided into what? 8. So your answer is 3 pi. Very simple. All right. DO, what is that? A radius. So the circumference, right off the bat, I just write down 6 pi. And then C to B to A is what? Yes, it is. 135. He's correct. However, listen to me now. I want you to try to reduce the fraction. See if you can listen to me, because I'm really, honestly, I'm trying to get you to think about the fraction, right? So, again, what did we say 45 was? An eighth. And a 90 is what? Yes. Right. So the total is 3/8. All right, that's how I kind of want you to think about it. All right, 3/8. All right, if you wanted to, you could just do what? 135 out of 360 and then reduce it, and you'll see it's the same as what? 3/8. All right, so now you're just doing 6 pi times 3/8, and once you reduce that down, we would say that's what? Wrong.
It's 9 over 2.
I think 9 pi over 4, right? Is everybody happy with that explanation? 9 pi over 4, right? Very, very simple. Come on. Yep. Okay, so now we're looking at the next one. MT, what is that? A diameter. So the circumference is 7 pi, and RT is 50, so it'd be 5 over 36, right? Right, crossing them out. 5 over 36, so my answer is 35 pi over 36. Are we agreeing? All right, so help me out with PR. What is PR? So the circumference? 26 pi, and I'm looking for MR.
MR would be 130.
Yes. Did I say how wide it's 130? Look at it carefully. Well, TR is what?
What would NR be?
TR is what? 50. So the rest of it has to be 130. Is everybody with me? Come on, guys, man.
Oh, yeah, I see it now.
Right? TR is 50, so RM is what we're looking for. Do you agree? 180. 180 minus 50.
Gotcha.
Right? So it's 130 out of 360, which is 13 out of 36. And then if we reduce that down, it should be 169 pi over 18. Is that right?
Okay, but I don't know.
I don't think 169 can be divided by 3. Because it's 13 times 13.
Yeah.
All right. All right, so MP, tell me what MP is. MP is,
A radius.
so the circumference, so it's 4 pi. And then MST, so the answer is just what?
No.
Just stop talking.
Like that.
Hey, you're just saying things.
2 pi, here we go.
A quote on the daily.
All right, MRS, so what is PS? So then the circumference is 20 pi. Now, MRS is how many degrees?
230.
230. Wow, look at that mental math.
Oh.
There we go, 23 out of 36. So then, I believe that's going to be 115 pi over 9. Is that right?
Why are you we wouldn't know.
Why are you what?
What?
We wouldn't know. Don't ask us.
Wait.
Yes, that's right. I did the math in my mind.
Oh, you know how Zach Coker was like the walking dictionary or something?
Yes.
He's the walking calculator.
It's just 20 and 36 can be divided by 4.
Jack Copeland's like 6'2".
5 times 23 is 115. Isn't that hard?
He was the walking dictionary.
Brother's like 6'1".
Carter's the walking geography.
Okay, that is an excellent explanation. You are welcome. Now you've got the next 2 worksheets. Finish up. Let's go. Chop, chop.
Can't possibly expect